Hello everyone, I am Tiago Batista from Coderversity, and in today's video you will be learning to master Elasticsearch queries with .NET. In today's video you will learn Elasticsearch Query DSL, basic search queries, range query, bool query, a fuzzy search, filtering versus queries, some practical examples while we explain it, and some query optimization tips. So, what are we waiting for? Let's dive in. I installed Elasticsearch and ran it using the Docker extension. Not extension, the Docker image, sorry. And to view our indexes, I use this app called ElasticView. So we are testing connection where our cluster is reachable and configured correctly. So once your Elasticsearch is up and running, the next step is to create an index. In Elasticsearch, an index is similar to a table in a traditional database, and it's where all of your documents are stored. Index creation allows us to define the structure and settings for our data. Let's create an index for our sample data. But before creating an index, we need to understand mappings. Mappings define how documents and their fields are stored and indexed. It allows you to control data types, whether fields are searchable, and if they should be tokenized for full text search. You can think of this like defining the schema in a database table. So now let's define an index in Elasticsearch using .NET and the Nest clients. For that, we will just create .NET project. Let's create a console app. Console app, here we go. And it's generating. Let's put it in desktop and call it Elastic Demo. Create project. And now, for simplicity's sake, we will write it all in the program. So, we'll create a new index called articles for storing blog articles and define mappings for fields like title, contents, and publish date. For that, we need to install the Nest package. So let's go to our terminal that is here. .NET add package Nest. Yeah, we have to go into the Elastic demo folder and run it again. Okay. Don't worry, I will leave all the links needed for you to be able to run this project in the description. So let's continue. Let's create an index and hold the response in this variable. And our client will be, we have of course to define a client, Elasticsearch Elastic client equals to new Elastic client, and this local host, that is our let me check the overloads. Actually, let's put clients dot yeah, okay. But I'm forgetting that to run the Elastic client, we have to initialize the settings in which we initialize a new connection settings with a new URI, well, where the URI will be HTTP localhost, like this, and then our settings are done. and we'll pass here the settings. And now, back to where we were, we put client.indices.create. Let's create the articles like I said previously, where we will map the article, and we will define our article in a second, to an automap that will automatically do the mapping for us. So let's create the article. That will be, of course, a class that we will create here, article, and will be something like public class article, and will hold the properties of an ID, a title, the content, of course, and a date time that will hold our publish date. So publish date get set. This will be our object article. I will explain all of this in a bit, so don't worry. And we define our properties, again with a lambda function, and our texts. So the automap automatically maps the C# article that we just defined class properties to the Elasticsearch fields, but we can override specific fields as needed. The text that I'm about to do defines the title as full searchable field. So in order to do that, we type the text as the name of the field, title in this case of the article, and this means that Elasticsearch will analyze it and make it searchable for partial or full updates, because I'm putting the analyzer as the standard analyzer. And the date that I'm going to do with the name of course, our publish date specifies that as you probably already guessed, that the publish date of the article should be stored as a date, allowing us to run range queries on it. And this creates the articles index and prepares it for storing documents with structured data like titles, content, and publish dates. The next step is seeding our Elasticsearch index with data. So I forgot here to add our basic authentication with our username, that in this case, based on the Docker image, is Elastic, and our password, that is your password. Let's also add here a code to, if the create index response is not valid, it shows us via console what happened, and something like failed to create index, and then we just type in create index response dot server error, else we just type in console.writeLine index created successfully. Let's give it a try. .NET run. Index created successfully. So let's go to our view. We are in the indices pages, and now we have the articles. Perfect. Now, to the seeding. So to seed data into Elasticsearch, we will use the index document method provided by the Nest client. This method allows you to insert individual documents into your index. So let's do it. Now we can comment this part since we already created the index, and we will create the articles in a list of article. Just a side note, if you want to randomly generate like multiple and a lot of objects, you can use the fixture library from C#. But in this case, let's create them. Let's create the articles by hand. Just format this. And our ID will be a GUID new with toString, and we'll have the title as Mastering Elasticsearch with .NET, and its content will have this is an in-depth guide on Elasticsearch integration with .NET. And our publish date will be a new date time defined by the year 2024. Actually, let's put 23 of May, day 15. And let's create another article. And not like this. And our ID will also be generated. So we can just copy paste. Let's actually copy paste everything and just change. For example, fuzzy search in Elasticsearch. And this, the content will be learn how to implement fuzzy search in Elasticsearch. And this will be in my favorite month because it was the month I was born, July. And we have another article. And now we will add them by doing for each var article in articles. Will index response equals to client dot index document article. So this will index our document for each article. And we are creating a list of articles or article objects and inserting them into the articles index using the index document method. Each document, as you already know, is assigned a unique ID and contains the title, content, and publish date. And with just a few lines of code, we've successfully seeded our Elastic index with sample data. So let's add it. Let's do again .NET run. And we got an error. Oh, of course, because we didn't define a default index when creating the actual index. So index document, and of course we have to do here the default index being articles. Let's format this a bit because that's the index we have here called articles. So let's run it again. Okay, let's check. So we have two documents like expected. And now it is time to search for some documents. We can start querying the index. Our index is populated with data. It's time to explore how Elasticsearch handles search queries. We will use query DSL, that stands for domain specific language, to build and execute queries. Nest simplifies this process by providing strongly typed methods for building queries. Let's put our hands into it. Let's comment this code to populate the index, and we will make a search in which we will hold the response in this variable using our client search by article, where our search will query and query, where we'll match our field title with the value of Elasticsearch. So this match query searches for articles where the title contains the word Elasticsearch, like written here. Nest's strongly typed API makes it easy to write queries in C# without needing to manually write JSON queries. So we'll build on this basic query concept as we explore more advanced searches and filters. Let's print our search response results. Search response dot documents. Actually, yeah, let's do a for each document in documents dot content. So let's run it. And we don't seem to be retrieving anything because I missed the Elasticsearch. So let's do something like this: document dot content, and let's bring in also the total results. Search response dot total. Let's see how this goes. So 2, and it gives us the contents of the two documents. As you can see here, we have the masterings Elasticsearch.net with these two documents and these contents that we successfully retrieved. So basically, this searches for articles, like I said, where the title contains the word Elasticsearch. Now, we will build on this basic query concept as we explore more advanced searches and filters. So let's go to the term query. So a term query searches for exact matches without analyzing the input text. It's useful for fields like IDs or keywords. So for example, we can maintain all of this, but instead of the match, we'll put term, and let's use just for readability here the term, and instead of query, we put the value, and let's put one of these IDs. Let's put the IDs of the document with the title fuzzy search, like this. Now, let's see what it retrieves. Not the title, we want the ID, and we want to check this ID and run it again. 0. Why is that? So it seems like with the match it works, but with the term is not working. Maybe this has to do with the mappings, because the keywords doesn't analyze. So let's go check the mappings. To check the mappings of an index, we can type in the index name and then mappings using a get HTTP method. And as you can see, the ID, the type is text, although it has a type keyword, the suffix of the ID. So what we can do is something like f.id.suffix keyword, and we will try again so that it doesn't analyze. And there we go. It brings the content of learn how to do fuzzy search in Elasticsearch according to this ID. Let's see if it corresponds. Fuzzy search, and it's this ID. Pretty nice. So, to review, a term query searches for the exact matches without analyzing the input texts. It's useful for fields like we just did, that is an ID or keywords. In this case, it was both. Let's go to the fuzzy search, which is useful for handling typos or misspellings in user input. Fuzziness allows Elasticsearch to run relevant results even when there are slightly variations in the search term. So, for example, if we go and instead of a term we do a match for our title, and we query Elasticsearch without di, so this has a typo, and if we run it, we can see that it's 0 because it's a typo. If we type in with the title containing the Elasticsearch correctly, it retrieves 2. So let's put again the typo, run it again just in case, 0, and let's add fuzziness. let's add an automatically fuzziness analysis. So this will account for the typo and still return relevant results. Fuzzy search improves user experience, especially in application with user-generated content. So let's run again. There we go. Pretty awesome, huh? Now, some tips for query optimization. Use filters and non-scoring conditions. Filters are faster and don't involve relevant scoring. Paginate results. Always paginate to avoid fetching too much data at once, since Elastic is so powerful and can bring so many results. And profile queries. Use the profile API to analyze query performance. If you want to know more about the documentation of Elastic, we can go to Elastic Nest and get the high-level client documentation. So here you can go to using the .NET client, and this will be in the description, of course. And for example, you have here usage examples, you have searching for documents, you have updating documents, deleting documents, and much more. Serialization, it's a world that you can explore. That wraps up our tutorial. I hope you found these projects helpful and that you learned something new along the way. If you followed along, congratulations on completing the project. Don't forget to like this video if you enjoyed it, and consider subscribing to the channel for more programming tutorials and projects. If you have any questions, suggestions, or just want to share your own version of the project, drop a comment below. I'd love to hear from you. Thanks for watching and happy coding. See you in the next video.